Welcome to Night Cosmos. Before we begin, take a deep breath and let the stars guide your thoughts. If you've ever gazed at the night sky and wondered what lies beyond, truly beyond, this episode is for you. Tonight we're diving into a question that blurs the line between science fiction and science fact. Could Interstellar become real? Inspired by Christopher Nolan's masterpiece Interstellar, we'll explore the real science behind wormholes, black holes, time dilation, and the possibility of humanity escaping a dying Earth to find a new home among the stars. But don't worry, we won't bombard you with equations or complex jargon. Instead, imagine yourself slowly drifting through the cosmos, surrounded by the quiet hum of the universe. This is your space to wonder, to learn, and most of all, to unwind. So, before we begin this journey, I have one small request. If you enjoy the peaceful journeys we create here at Night Cosmos, consider subscribing to our channel. It helps us keep the stars within reach. Now, let's begin our journey across the galaxies. When Interstellar hit theaters, it didn't just entertain, it sparked imagination. Could what we saw on screen actually happen? The idea of bending space, skipping across time, and venturing into the unknown resonates deeply with our collective curiosity. And here's the fascinating part: a surprising amount of the movie is grounded in actual science. Kip Thorne, the Nobel Prize-winning physicist who consulted on the film, ensured that many of the space phenomena were portrayed as accurately as possible, or at least within the limits of what current science allows. Wormholes, for example, are not purely fantasy. In fact, Einstein's equations allow for their existence. They are theoretical tunnels through space-time, shortcuts that could, in theory, connect distant parts of the universe. We haven't found one yet, but we also haven't ruled them out. In this episode, we'll break down these mind-bending concepts and examine what science says about their feasibility. So let your thoughts wander, because tonight, we imagine the impossible becoming real. The story of Interstellar begins with a quiet urgency, a need to explore beyond the stars. It reflects a deep human trait, curiosity. For centuries, we've looked to the sky with questions, dreams, and hopes. Space has always been more than a mystery. It's been a canvas for our imagination. Today, scientists and visionaries are building on that curiosity with technology and determination. Concepts like space colonization, advanced propulsion systems, and long-duration missions are not just theories, they are plans, carefully studied and gradually tested. The journey to other stars might be long, but every mission, every discovery brings us closer. The stars are not as far as they once seemed. Tonight, we imagine that maybe, just maybe, the path to them has already begun. In Interstellar, a mysterious wormhole appears near Saturn, a doorway to distant galaxies. This concept isn't just cinematic magic. Wormholes are rooted in Einstein's theory of general relativity. They represent bridges between two distant points in space-time, like tunnels that bend the fabric of reality. While we haven't observed one directly, the mathematics behind them is sound. Some solutions to Einstein's equations predict these phenomena. To travel through one would be like stepping across a folded page, moving between stars in moments rather than millennia. For now, wormholes remain theoretical, but they offer a beautiful possibility that the universe may hold shortcuts waiting to be discovered. Imagining them is part of imagining our future among the stars. Wormholes might sound like pure science fiction, but physicists take them seriously, not because we've seen one, but because our current understanding of gravity allows for them. Kip Thorne and his colleagues have published scientific papers on how they might work. One idea involves something called exotic matter, a substance with negative energy density that could hold a wormhole open. We don't know yet if such matter exists, but quantum physics does hint at strange possibilities. The Casimir effect, for example, shows that empty space is not truly empty, it's filled with fluctuations in energy fields. If nature can bend those energies just right, maybe wormholes aren't as far-fetched as they seem. Interstellar also brought us to the edge of a black hole, a swirling giant called Gargantua. Its design was so scientifically precise that it ended up being published in research journals. The visual effects team worked closely with physicists to simulate how light would bend around such a massive object. The result was both stunning and educational. Black holes are real. We've even photographed one. These cosmic phenomena compress mass into an incredibly small point, curving space-time so strongly that not even light can escape. Around them, time slows dramatically. What looks like minutes near a black hole could be years for someone farther away. This effect, known as gravitational time dilation, is real and is one of the wildest aspects of relativity. Gravitational time dilation might sound like a plot device, but it's a measurable, real phenomenon. Even GPS satellites must account for it, as time moves slightly faster up in orbit than it does on Earth. But near something as dense as a black hole, this effect becomes extreme. In Interstellar, a single hour on the surface of a planet near Gargantua equals 7 years on Earth. While such a scenario requires very specific conditions, the physics checks out. Time and space are not constants, they are flexible, shaped by gravity and motion. This means that under the right circumstances, time travel, at least forward, is not only possible, but already happening in subtle ways. If we ever hope to reach distant stars, we'll need more than wormholes and black holes. We'll need propulsion systems far beyond what we have today. Chemical rockets are useful but slow. At their current speed, reaching even the nearest star would take tens of thousands of years. That's why scientists explore other concepts: ion drives, fusion engines, even antimatter propulsion. These technologies promise higher speeds and better efficiency. One idea, called the Alcubierre drive, suggests bending space around a ship, shrinking space in front and expanding it behind. It's theoretical but exciting. The future of space travel might not be faster engines, but smarter physics. Fusion propulsion is especially promising. It mimics the process that powers stars, fusing light atoms to release immense energy. If harnessed, it could propel spacecraft to a significant fraction of the speed of light. Projects like the Daedalus and Icarus concepts envision massive fusion-powered ships capable of interstellar travel. These designs aren't fantasy, they're carefully constructed studies based on real physics. Challenges remain, of course, but progress in fusion research on Earth brings hope. As we master the energy of the stars, we might one day ride that same fire to other worlds. In the film Interstellar, the astronauts journey to worlds orbiting a massive black hole. These exoplanets, although fictional, represent a real and growing field of study. Scientists have already discovered thousands of exoplanets, planets orbiting stars outside our solar system. Some of them lie within the so-called habitable zone, where temperatures could allow for liquid water. Telescopes like Kepler, TESS, and the James Webb Space Telescope continue to reveal new candidates, analyzing their atmospheres and light signatures. One day, we might even detect biosignatures, signs of life in alien skies. The dream of finding a second Earth is no longer distant science fiction. It's an ongoing effort guided by curiosity, patience, and ever-improving technology. And though these planets are far away, the idea that one could become a future home inspires both scientists and storytellers alike. Every exoplanet discovered brings us one step closer to understanding our place in the cosmos. Communication plays a key role in any long-distance journey, and interstellar travel would bring new challenges to how we send and receive information. Light speed delays would mean conversations across stars would take years. Yet even within this limitation, scientists explore ways to keep deep space crews connected to Earth. Laser communication, for instance, offers much faster data transfer than traditional radio. NASA's experiments with laser systems could someday allow high-definition video calls from deep space. Quantum entanglement, though highly theoretical for communication, has sparked curiosity about future possibilities. But perhaps more important than real-time communication is data preservation. AI systems, autonomous decision-making, and vast onboard databases would empower crews to solve problems without waiting for Earth's guidance. In the world of Interstellar, astronauts act with independence, supported by intelligent machines like TARS and CASE. These fictional assistants reflect a very real trend in robotics and artificial intelligence. Machines are already helping astronauts aboard the ISS, and their roles will only grow as we venture farther from home. Artificial intelligence is no longer confined to science fiction. It's becoming a vital partner in space exploration. In Interstellar, the robotic assistants TARS and CASE are not only helpful, they're personable, ethical, and often humorous. While we haven't built such advanced companions yet, the concept is rooted in today's reality. AI systems already assist mission planning, analyze scientific data, and control autonomous drones on other planets. The NASA's Perseverance rover, for example, navigates Martian terrain using onboard machine learning. As missions grow longer and more isolated, AI will provide more than technical support. It may become an emotional anchor. Imagine a future where a ship's AI knows the crew, tells stories, or adapts to moods. These systems could ease stress, reduce loneliness, and improve decision-making under pressure. Just as TARS crack jokes to lift spirits, future AI companions may become essential crewmates. Whether in orbit around Earth or on a voyage to another star, intelligent machines will help carry us farther than ever before. Long-term space travel brings unique challenges to the human body. Weightlessness, radiation exposure, and psychological isolation are key factors being studied in preparation for missions to Mars and beyond. On the International Space Station, astronauts already experience bone loss, muscle atrophy, and changes in vision due to microgravity. Countermeasures like exercise routines and nutrition plans are being refined to mitigate these effects. Interstellar travel would amplify these challenges, but it also inspires new solutions. Rotating spacecraft could simulate gravity through centrifugal force, preserving physical health. Advanced shielding materials, like hydrogen-rich plastics or magnetic fields, could protect against cosmic radiation, and perhaps most importantly, maintaining mental well-being during a years-long journey would require a balance of structure, companionship, entertainment, and purpose. Psychological resilience, as shown by the characters in Interstellar, might be just as vital as engineering. Preparing for such missions means training not only the body, but the mind. With each experiment aboard current space missions, we're learning how to adapt the human experience to the vast quiet of space. One of the most mesmerizing ideas in Interstellar is the concept of love as a force that transcends time and space. While not a scientific principle, this theme speaks deeply to human motivation. Why do we explore the unknown? Often it's not for discovery alone, but for connection, to protect, reunite, or remember the people we care about. In reality, missions to deep space will be powered by the same emotional currents, whether it's sending a message across the solar system or returning to Earth after decades. Astronauts will be moved by the same timeless forces that shape our lives here. When building the future of space travel, it's important not to forget the human heart, the stories we tell, the memories we carry, and the people we love. These are what will guide us through silence and stars. And as strange as it may sound, perhaps emotion will be one of the most powerful engines aboard a ship bound for the unknown. A journey to another galaxy might seem like a fantasy, but even within our own Milky Way, the possibilities are breathtaking. With over 100 billion stars, each potentially hosting planets, our galactic neighborhood offers countless destinations. Technologies being developed today, like powerful ion engines, magnetic sails, and advanced cryogenic systems. One concept, Breakthrough Starshot, proposes sending tiny spacecraft at 20% the speed of light to nearby stars using powerful laser propulsion. Though these missions are unmanned, they represent the first real steps toward interstellar reach. And just as early ocean explorers once ventured beyond sight of land, today's scientists are charting paths through the darkness between stars. The idea of reaching another solar system is no longer dismissed as pure fiction. It's an audacious goal, but one that is slowly becoming technically conceivable. And as we refine our tools and expand our vision, our first real leap beyond the sun may come sooner than we expect. Suspended animation or putting astronauts into deep sleep is a concept often seen in science fiction, but what if it could become real? In the context of long-duration missions, especially interstellar ones, reducing human metabolic activity could solve many problems. It would conserve resources, limit psychological stress, and reduce the burden of space travel on the human body. Today, researchers are exploring therapeutic hypothermia, where body temperature is lowered to slow metabolic functions. It's already used in some medical procedures on Earth. If scaled and refined, it could lead to technologies that gently place humans in a state of safe, extended rest. In Interstellar, cryosleep was portrayed as a common practice for interplanetary travelers. Scientists now take such ideas seriously, not as current realities, but as future innovations worth exploring. While the full vision of hibernation is still distant, its early forms may one day be integrated into the toolkit of interstellar exploration. A long sleep among the stars may not be fiction forever. The concept of time travel has fascinated humanity for centuries, and Interstellar offers one of the most grounded portrayals rooted in real physics. Time, according to Einstein, is not absolute. It stretches and contracts depending on speed and gravity. This is why astronauts on the International Space Station age ever so slightly slower than people on Earth. In more extreme environments, like near a black hole, this effect becomes dramatic. It means that under the right conditions, we could theoretically move into the future by simply experiencing time at a different rate. While we can't yet move backward in time, forward travel by means of time dilation is supported by current scientific models. Interstellar brought this idea to the forefront in an emotionally charged way, showing how characters were separated by decades due to relativistic time. It reminds us that in space, time is not just a ticking clock, it's a flexible fabric shaped by motion and mass. The further we reach into the universe, the more this truth will shape how we understand and experience time itself. Another fascinating element of Interstellar was its depiction of a fifth-dimensional space, a place where time could be seen and moved through, like a landscape. This concept was visualized as the Tesseract, a physical manifestation of higher dimensions, where past and future were accessible. While this is speculative and deeply theoretical, it is not without scientific roots. The idea of higher dimensions comes from advanced theories like string theory and M theory, which suggests the universe may consist of more dimensions than the four we experience, 3 of space and 1 of time. These extra dimensions, if real, could help explain the fundamental forces of nature and even unlock new methods of travel or communication. Though we haven't confirmed them, the mathematics is intriguing and continues to be studied. Thinking beyond our perception challenges the imagination, but it also opens up new frontiers. Just as ancient thinkers once believed Earth was flat, we too may be standing at the edge of a much deeper reality. The idea of humanity becoming a multiplanetary or even multistellar species is more than a fantasy. It's becoming a long-term vision. Visionaries like Carl Sagan, Stephen Hawking, and Elon Musk have all argued for the necessity of spreading life beyond Earth. Not out of fear, but out of potential. Earth is beautiful and precious, but it is also fragile. Exploring and settling new worlds could serve as a kind of backup for civilization, a way to preserve knowledge, culture, and life itself. The technologies we develop to survive elsewhere often end up improving life on Earth. Clean energy, recycling systems, advanced agriculture, all of these benefit from the challenges of space exploration. So while the idea of leaving Earth might feel distant, the path toward it enriches our present. And maybe, just maybe, one day we will look back from another star and remember the moment when our journey truly began. Interstellar didn't just show space as beautiful, it made it feel personal. Every choice, every moment had meaning. It wasn't about technology alone, but about humanity's courage to face the unknown. And in the real world, the same principle holds true. Every discovery in astronomy, every mission launched, is a story of people daring to ask, what if? It's easy to feel small in the vastness of the cosmos, but space is not just empty. It's full of questions we're only beginning to ask. The silence between stars is not lifeless, it's a canvas. A place where imagination, science, and emotion meet. As we move into a future of advanced space travel, we carry with us not just equipment, but dreams. Not just math, but meaning. That is what gives our journey depth. The stars are not only out there, they are within us too. Every generation leaves behind a legacy, a map of dreams shaped by the stars they chased. Today, our generation stands on the edge of space, watching the boundaries between science fiction and science fact slowly dissolve. Interstellar served as a mirror to what might be, and now science begins to reflect that vision. Telescopes peer deeper, rockets fly higher, and minds imagine bolder. We are no longer asking whether interstellar travel is possible, but when and how. The more we learn, the more we realize the universe is not a limit, but an invitation to explore, to grow, to connect. Whether we travel in physical ships or through the vessels of imagination, we are already on our way. This journey may take decades, centuries, or more, but it has already begun. And with each quiet night spent under stars, more hearts awaken to the call. As our journey tonight comes to an end, I invite you to take a deep breath and simply float. Imagine yourself aboard a ship drifting gently through the cosmos. The stars slow dancing around you, time itself softened by distance. Whether interstellar travel becomes real in our lifetime or in lifetimes yet to come, the dream is alive now, and that matters. What we believe, we build. What we imagine, we pursue. So let the wonder stay with you, even as sleep begins to settle in. Here at Night Cosmos, we believe in peaceful minds, curious hearts, and the beauty of dreaming big. Thank you for spending this time among the stars with us. If you haven't yet, consider subscribing to the channel. It helps keep this cosmic journey going. And now, close your eyes, let go of today, drift gently into night. From all of us here at Night Cosmos, good night, dreamer.